Hello, Algebra 2. We've made it to lesson 2 of week 2, and we're going to go ahead and talk about graphing polynomials. So this week's lesson is really going to focus on what the graph is doing when it approaches or crosses the x-axis. There will also be a little bit of practice from last week's material, just a little bit, and you'll see that in your reflection questions, one of them. Okay, we're going to start off with a polynomial function that has been factored. We're only going to have factored polynomials, guys. You'll be working with, based on what you know about linear, quadratic, and cubic functions, we're ready to graph this factored polynomial. And the reason why is it's already kind of broken down as to what's going to happen right at the x-axis. Okay, so the first step is to always draw the x and y axis. Now that's if you don't already have one. You'll notice on your practice sheet that there is not an x and y axis, and you're just going to sketch it. That's it. Next step is you're going to go ahead and you're going to find and plot the zeros of the function. Now when we're talking about the zeros of the function, we're looking at where each one of these binomials or single term is going to equal 0. So the way we're going to do that is we're going to set them all equal to 0. So x squared equals 0, x minus 1 cubed equals 0, and x plus 2 equals 0. That one really didn't need the parentheses. All right. So this first one, the next step is to go ahead and square root both sides, and x just equals 0. And then this one, we would end up the cube root of both sides. So we would have x minus 1 equals 0, and then x equals positive 1. All right, this last one we just have to subtract x over to the other side, so x equals negative 2. So we have our three solutions, or three zeros. One of them is located at x equals 0, so I'm going to put a little dot right there, or point. Okay, another one is x equals 1, and x equals negative 2. Okay, so those are our 3 points that we're going to kind of investigate. We don't know what's happening as far as if the graph is going to start here, go down, up, over. Back up. We don't know anything about this graph except for the fact that it crosses here, or it touches or crosses here, touches or crosses here, touches or crosses here. Okay, so it could start here, go up, and then come back down, touch, okay, go back down. It doesn't come back up though, okay? So let's go ahead and kind of see what's going on. So that's where the sign analysis comes into play. So using sign analysis, we can go ahead and kind of substitute some information in, go away, or test some points to see if it's going to go above or below that x-axis. Okay, so I'm going to first start off with kind of looking back at those points. So I know that I have one point at negative 2, another at 0, and another at positive 1. Okay, now if we're testing some points, I need to test a point on this side of from negative 2 to negative infinity. So when I'm looking at that, I'm really looking at the domain interval of negative infinity all the way to negative 2. I do not want to include negative 2 because if I do, that's a solution, so it will definitely be equal to. Okay. My next point is going to end up being, this is my test point. So my next point is from negative 2 all the way to 0. So I need to test a point in between those two values. Okay, and we're going to test a point between 0 and positive 1 to see if our graph is going to go above, which would be positive, or below, which would be negative. In the last domain interval, I'm going to look from 1 all the way to positive infinity. Alright, so if I need to find a point between negative infinity to negative 2, I'm going to choose just a random point in between. On my filled out notes, I'm going to go ahead and stick with those points. If you already have that, that's awesome. You can kind of follow along with that. Okay, so I'm just testing negative 5. Like I said, you can test -6, -7. It's up to you. Now, when I test -7, and I really need to put this function back up here. I should have done that. So hopefully that'll be fixed for you. Okay, but I'm going to substitute it right back into my equation. X squared times x minus 1 cubed times x plus 2. Okay, and I'm substituting it back in. Now I only really care about the positives and negatives, but for this very first one, we'll go ahead and substitute the -5 inside my function. Okay, so I end up with x squared, which instead we're going to test that x equals -5. I'm sorry. There we go. Okay, so it's going to be -5 squared times x minus 1, which x is actually going to end up being -5 minus 1 cubed, -5 plus 2. -5 squared is going to end up being positive 25. So that's going to be a positive value. -5 minus 1 is going to be -6. And then -6 cubed is going to give us -216. And then -5 plus 2 is going to give us -3. Alright, so really, in the future, we're not going to worry about the math portion of it. We care about whether the sign is going to be positive or negative, and I'm going to show you why in a moment. Okay, so -216, that's just going to give us our negative sign. -3 is negative. Okay, so we're going to end up with a positive number times a negative number times another negative. So what's negative times a negative? That's going to give us a positive times positive, which is give us a positive solution overall. So at the very beginning, we know that this graph is going to approach the x-axis from the positive side. Okay, so we're going to end up with our positive side on this, and then it's going to approach, it's either going to cross point of inflection or be tangent to this point right here. Okay, but we need to figure out what's going on the other side of the graph, on the other side of that point. So we are going to go ahead and test another value in between -2 and 0. So a number in between -2 and 0 is actually, we're going to test -1. So when x equals -1, we're going to see what's happening within this function. So we're going to end up, our first term is really -1 squared. -1 squared is going to become positive. And our next one is going to end up being -1 minus 1, which is -2. A negative number cubed is actually just going to be negative. Now, our last one is going to be -1 plus 2, which is going to become a positive 1. So we end up with the three values. Positive times a negative times a positive is going to give us a negative value. So our graph is going to go below the x-axis. All right, let's go ahead and take a look. We're going to test a number between 0 and 1, and, well, it doesn't look like we have any integer numbers that we can test. So I'm actually going to test 0.5, which is right in between. So we're going to say x equals 0.5, and it is okay to test decimal answers because there's infinite many numbers between 0 and 1. So we're going to go ahead and substitute it into our original. So remember, a positive squared is always going to be positive. 0.5 minus 1 is going to end up being negative, and negative cubed, because a negative times a negative times a negative is still going to be negative. And then we would end up with a 0.5 plus 2, which is going to be a positive 2.5. Okay. So if we were simplifying this further, and this is why we're only focusing on the sign itself. It's a sign analysis rather than calculating every single one. So positive times a negative, that just becomes negative times positive. Positive times a negative, it just becomes negative overall. So we're going to still be down here on the graph. All right, next problem. We need to pick a number between 1 and positive infinity. Okay, so let's try 5. So we have x equals 5. If I substitute 5 back into my function up here, I end up with 5 squared, which is positive 25. Then for the next term, I end up with 5 minus 1. 5 minus 1 is 4. and we would end up with positive 4 cubed, which would just be a positive number. And then we end up with 5 plus 2, which is 7. That's also positive. Positive times a positive times a positive is going to give us a positive value. So I know over here, that's going to go ahead and start in the positive direction. All right, so this is what I do know. Okay, I don't know, it is just a sketch, but as it goes forward, if I have from positive to a negative, I'm going to do two things. I'm going to either cross or I'm going to have a point of inflection. Okay, now there is something that kind of gives away what's happening at this point. So as I'm looking at, should use some other colors here. Whoops, back up. If I'm looking at -2, that's going to be part of this binomial right here. Now, if you look, this is to the first degree. Okay, if it's to the first degree, well, back up. Apologize. Let's go ahead and take a look at what the graph's doing. So I know the graph is going to start here and go down, cross over. Okay, now it's going to, I don't know what's happening between here and here, but I do know from here to here it has to come back up, but it's not going to cross over to the other side. It has to come back down into being in the negative direction, and then it's going to continue on. Now, it is going to do something a little different here because our polynomial has a cubic, so that's going to be x minus 1 cubed for this portion right here. So when it is cubic, that's going to be our point of inflection. So it's going to do kind of like a wiggly worm kind of turn here. Okay. Because it's to the third power. So that's going to be our point of inflection. Looking back at the first portion, this is our binomial x plus 2. Now that's to the first degree, so whenever it's to the first degree, that's just going to cross. And that's crossing right at -2. I'm going to erase this so it doesn't get confusing. Okay. Now, right here, our binomial, or in monomial in this case, is just x squared. Okay, and x squared is kind of like a quadratic equation, so it's going to be tangent to the point 0 right there. So this is going to be tan, or tangent. So I have three definitions going on. So if it's to the first degree, it's crossing. If it's to the second degree, it's the polynomial is tangent to the x-axis. And we have a point of inflection, POI. Okay, and that means it's going to kind of have a squiggle right there, and that's called the point of inflection. All right, let's go ahead and move on and see what we can do. If we were given the graph and we had to work backwards, we would start off with locating the zeros. That's going to be our first step. Okay, so our zeros are located at -3, -1, and 2. So at -3, notice how it does cross. So I'm going to go ahead and label that it crosses. And when it does cross, that's going to end up, or represent that it's going to be kind of like a linear equation or a binomial to the first power. So that's going to end up being x plus 3, opposite what you think, because it's -3. It needs to be +3 on the inside of the parentheses. Okay, so if I start writing out my equation, which is your third step, it's going to be f of x equals x plus 3. Okay, and that's for the first solution. The second one is where it crosses at -1. That's going to end up being and it's a point of inflection. So point of inflection equations are cubic, so that's going to be x plus 1 cubed. And our last one is going to end up being tangent, which tangent would be x minus 2 squared. You do not need to FOIL this out. This is as far as you need to go as far as the factored form of the equation or the polynomial. Okay, now last but not least, please, if you're struggling with this online digital learning or if you just have questions about what to do, this is how you can contact me. My Google Voice number is right here. My